Okay, so on this video we discuss the balancing chemical equation. Okay, so we have the some two methods, no, of these slides later on. Okay, then I will show you the how to determine or to solve in terms of balancing chemical equations. Okay, so I have two example problem. Okay, so on this balancing chemical equation, so it means a chemical equation is a written symbolic representation of a chemical reaction. So the reactant chemicals are given on the left hand side and the product chemicals on the right hand side, no? Then the law of conservation of mass states that no atoms can be created or destroyed in a chemical reaction. So the number of atoms that are present in the reactants has to balance the number of atoms that are present in the products. Okay, so by the way, in studying the chemical reaction, no, or the balancing equation, no, is very important because it tells the number of moles or that producing or reacting, no. Then also the amount of electrons that transferred from one compound to another. Okay, so or the energy changes that take place, no. Ano siya, the law of the conservation of mass, no. Okay, so by discovered ni Antoine Laurent Lavoisier, no. Okay, so next, so we have the first method in balancing technique. Okay, so for example, given the following unbalanced equation, which is C3H8 plus O2, then to H2O plus CO2, no? Okay, then solve the coefficient of the O2, no, to the balance equation. Okay, so for step 1, we write down the number of atoms per each element on each side of the equation. Okay, so we create the table, no. Okay, so for the carbon, which has 3, and for the hydrogen is 8, then for the oxygen here is 2. Okay, so this can be our left side, no. Then the right side as this, no, which C here is equals to 1, then H is equals to 2, then O here is 3. Okay, so we have 1 oxygen here, and then the other is 2, so that is the total of 3. Okay, so take note that always leave the hydrogen and oxygen as the last one to balance, no. Okay, so if you have more than one element left to balance, so select element that occurs in only a single molecule of reactants. Okay, so and in only a single molecule of product also, no. Okay, so for the step 2, so balance the carbon atom first, no. Then click note, we can multiply CO2 by 3 in order to get 3 on the right side. So this can be here, ang carbon here is atong gi-multiply ng 3, so that is equals to 3. Then also we have the carbon here of the combination, no, which is 1 plus 2 times 3, that is 7. The next, balance the hydrogen atoms next, so multiply H2O by 4 in order to get 8 on the right side, no. So you know, we can now multiply by 4 here. Okay, so since in this case our carbon here is equal to this left hand sa carbon, no, so sa imong chemical formula, then another is we can now multiply by 4. Okay, so since two atoms of hydrogen, so which is 2 times 4, that is 8, no? So we can now obtain the same as H in the left side, no? Then the other is 4 times the 1 atoms of oxygen, then plus 3 times the 2 atoms of this, no, of the oxygen also. So we have 10. Okay, so since our right side is 10 and then the left side ito is 2, so we have the step 4, no? So to balance the oxygen atoms next, so multiply oxygen, no, in the left side, no, which is multiply na to siya of 5 to obtain 10. So therefore we can now balance. Okay, so in this case, so by the way, this is a balanced chemical equation na for this example given. But ang to find the coefficient of the oxygen, which is in the 2 atoms, no? Okay, so we have here 5 O2, no? Okay, so we cannot say here our coefficient because we have 2 here, but that is our CO2, no? Then we can say that the coefficient of CO2 is 3. Okay, so since the problem say find the coefficient of this oxygen, which is the which is have the 2 atoms, no, which is 5. So therefore this is the final answer. The coefficient of oxygen 2, or we have 2 atoms here, that is 5. So that is the final answer.